We'll be exploring reality capture assets in the real-world conditions. Let me welcome to the stage the CEO at Nubigon, Bert Azizoglu. Bert, welcome.
Hello, everyone. I know it's late, so I'll keep it light and sweet. We've seen a lot of very inspiring talks over the past 2 days. And I think there were a few main takeaways that I've seen occur throughout these presentations. One was obviously the power of storytelling, the potential of Gaussian splatting, and the importance of making the data that we collect more understandable. So over the course of the next 20 minutes, I'll be talking about how we can take these lessons and implement them into day-to-day reality capture and scan-to-BIM project presentations. Me and my team at Nubigon, we develop a software where we specialize in visualizing and animating massive point clouds, Gaussian splats, CAD, BIM, and mesh models. Our main mission is to help our users to showcase their projects, to help explain the value proposition that they have, elevate them from the competition, and ultimately enable conversations with non-technical decision makers. Now, there are a lot of things that have changed over the past year, and the expectations that people have are also adapting to that. So what do we need to do in order to present our scan-to-BIM projects as effectively as possible? The video that I'll be showing you in a second is a heritage scan-to-BIM project from Serbia, and it portrays a combination of a point cloud, a high-resolution point cloud, a BIM model that has been automatically aligned, as well as a CAD drawing. And I think it's a good way to start this conversation about the importance of showcasing scan-to-BIM projects. So this is just a very short 1-minute video. I hope you can sit back, relax, and enjoy this. And I'll be with you right after this. I think it's very important to emphasize the connection between scans and derivative digital assets, because that's really the value of scan-to-BIM, that BIM models are actually anchored in reality and therefore provide trust to people that are using these derivative assets. This project that you've seen was captured by Milos Radin and visualized by Bert Azizoglu. Now, how does Gaussian splatting come into this? Last year, at this stage, we've announced our support for Gaussian splats with a built-in level of detail that has spurred a whole host of beautiful renderings of Gaussian splat projects. And it has also triggered a lot of conversation about how can we integrate and use Gaussian splats in the scan-to-BIM pipeline, as well as the scan-to-BIM project presentations. Now, Mindy and her team at Xscript have been very collaborative in this regard, and we've been actually able to connect with Philip Posch. I don't know if he's in the audience right now. Is he? I don't see him right now. He's a colleague of ours working in Austria, and he's one of the first ones to deploy the Xscript scanners to actually complete an entire scan-to-BIM project. Now, there are obvious concerns about accuracy when it comes to using Gaussian splats as the core input for developing BIM assets. And obviously, these concerns are quite valid, at least for the time being. However, there's a short-term implementation that we see great value in, and that is adding Gaussian splats to the entire scan-to-BIM presentations as an additional validation layer. So I invite you to check out this rendering that we have done in Nubigon that combines a layer of Gaussian splats, point clouds, and derivative BIM models, and really helps the user to trust and develop an understanding for the quality of the data. Now, there are a number of valuable lessons to be taken from this video. First and foremost, as Christoph has previously mentioned as well, alignment is key. And now, in this case, an alignment of different various assets. So we have two components here. Xscript is delivering the point clouds and the Gaussian splats, which are inherently aligned. And we are enabling essentially an alignment between point clouds and BIM models. So altogether, you can create these hybrid scenes that consolidate all of these assets in the same coordinate space, which allows you to iterate and differentiate between layers during your process. So it improves the scan-to-BIM pipeline itself, as well as the demonstration of the deliverables. Great. Now, where do we go from here? What's the next step in terms of improving the presentations of scan-to-BIM projects? We've seen a lot of examples since yesterday morning that improve the captured data with additional features. You saw the presentation of Tomasz Banas about Machu Picchu, where he added incredible layers of light and various other Unreal-based elements. We've seen a whole host of other amazing examples from the VFX and media space, where reality capture data is embellished to make it more understandable and accessible. Our goal with this next version update that we are announcing today is actually to bring a lot of these lessons into the scan-to-BIM world. Let's start with point clouds, the workhorse for all scan-to-BIM projects. It offers incredible levels of accuracy and is the starting point for every analysis that requires spatial accuracy. So here we have a great project captured by Shimon Bloch and his team at Scan3D. They have a booth outside. This is a beautiful capture. It's a point cloud of about 300 million points captured with a drone photogrammetry and a terrestrial laser scanner. And when it comes to scanning and LiDAR scanning especially, this is as good as it gets. There are also barely any baked shadows, so it is a really ideal scenario. But obviously, these scans don't look realistic in an intuitive way. these are not. These buildings that we have here, this is a church in Hamburg, don't exist in a vacuum. Now, what if we could add light sources to the scene and make them look like as if we would expect them in real life? By simply adding the location, the day, and the time, we're actually enabling our users to recreate real-world light configurations. This is obviously not only a great way to improve the quality of demonstrations, but also has quite significant, offers quite significant opportunities to explore the site in a new way. Now, again, this is the starting point. And by deploying a whole host of techniques that are probably familiar to many from the VFX and Unreal ecosystem, we are using direct and indirect lights. We are introducing shadows, physically based rendering, ambient occlusion, shadow. We have turbidity, bloom, etc., etc. Now, these are all terms that you really don't have to know, because creating these lights and shadows configurations are simply done by a few clicks and entries. Ultimately, from an analysis perspective, you're able to recreate daytime animations, sunrise and sunset simulations, and analyze the interaction between various assets in your scene. Shadow analysis is obviously a huge potential use case for these. Now, once we have this capability, obviously it makes sense to apply to BIM models as well. A lot of times, users that develop BIM models are simply, creating captures from Revit and leave it at that. That's a hugely missed opportunity. By simply adding a little bit of light, you can create a lot more appealing displays, as well as a better understanding for how light interacts with the buildings in your scene. This is a data set that Michael Gula provided to us way back and has been used for many demonstrations in the past. And this is just a great way to demonstrate how you can also create incredibly interesting and appealing visuals from, one might say, somewhat boring assets. But it has also a functional purpose. If you have assets that are exposed to sun and you're curious about how exposed they are to the elements, this is a great way to analyze different viewpoints and days in the time and time in the year. And it's also a pretty neat way to make your data look a little more sexy. From a technical standpoint, you can create animations that allow you to simulate how your office, for example, would look like and how much sun it would get throughout the day. Now, there are obviously some applications that do some parts of these, but the benefit of having this in Nubigon is that you can apply it to the entire spectrum of scan-to-BIM deliverables, all in the same space, without having to worry about anything else. And the real killer in my eyes is to combine various assets. So here we have a historic block from the UK, captured with aerial photogrammetry, rendered as a point cloud in the scene. And adding lights give you a sense of how much shadow this soccer field in the middle would get, or how much light a building placed into that location would be receiving. Similarly, you can just change your vantage point and develop an understanding for how much sun your balcony would be receiving throughout the day. In this case, we have the transition of the sunrise coming up on your balcony. Nice. So I hope this was inspiring, and I'm hoping that this will help the industry in general to keep up with the increased expectations of increased photorealism that Gaussian splats are triggering, as well as new ways of incorporating Gaussian splats into your scan-to-BIM pipelines. And I think I'll leave it at here. We're good on time.
Perfect.
Thank you so much.
Let's give it up for Bert. Thank you so much. Thank you. And we have actually time for one question. You didn't go over time, so let's take a look at it. So is light rendering in Nubigon in real time?
Yes, it is in real time, and it applies to all the assets that I've just alluded to.
Perfect.
Yeah.
Well, if you're going to have any further questions, please find Bert and just continue with that conversation. Bert, thank you so much.
Thank you.
Let's give it up for him one more time.